Hello everyone. In this video, I would like to talk a bit more about our simulated switch connector that we have. As we said, this one is simulated, so we need to configure it. Therefore, this one at the end has a simulation configuration page. In here, you define some parameters like the system name, system description, model configuration, all parameters that you can set in the device itself, but needs to be configured. Like in here, we define the interfaces. Each entry can be configured separately. Like here, how do you read it? I want to have 48 interfaces of this type with this MTU of 10 gigabits and a flow max of 100. The flow max, that's something that we will use for the SDMN concept. I'll come back to that in another video. Next to that, I also want to have 8 interfaces with same MTU, same type, and a speed of 40 gigabit with a flow max of 400. I define a bitrate over here of a maximum bitrate of 200 gigabyte per second. This is the max bitrate that the switch will allow. More of that later. And once everything is configured, I just hit the deploy and the interfaces are created in the interfaces table. Do note we have some predefined settings for a leaf spine setup. In this case, I just did a manual setup. And when I go to my interfaces, you see that I have over here all the interfaces added in this table, 48 interfaces of 10 gigabits and 8 interfaces of 40 gigabits. So this interface table, we tried to have a copy of a real one, like that you can find on other switches. So you also have admin status, operational status. For simulation purposes, we added a physical connection column in here. So what does this do? This just simulates if an Ethernet cable is plugged in or not. So if I put this value to no, you will see my admin status is still up, but my operational status changed to lower layer down. Also, last change gets adapted like it's done on a real switch device. Then we have some additional info like RX flows, RX bitrate, RX utilization, the packet drops, and the same for the TX. And then we have some special columns at the end prefixed with resbooked. This is for our SDMN solution that we're creating. So I'll come back to that later, but one thing that is might be important now is, for instance, the unexpected high. Why do we have that? Well, we have a flow over here. So we can see that our RX bitrate 10 gigabit per second, while our SDMN solution doesn't expect a flow running through it. So therefore, he's mentioning unexpected high over here. So these are both the interfaces. I just said flow. How do we have flows? We have that by creating a flow in the multicast table. So in here you see what's coming in the switch and what is going out. To do that, I already showed that in another video, but I will be happy to show it again. Like we select one of our Ethernet ports, we go to the multicast tab page over here on the visual, and it's just say add multicast. And here I define my incoming switch port, my outgoing switch port, which I will take an active one. In this case, I will take 10. I define a bitrate. For instance, I see there's already a bitrate of 10,000 on this one. So it takes the maximum bandwidth of the Ethernet port. So if I just define one of 1000, I'll give it my initials as label. And let me try to have it also of the same service class, because in that case, we will have some packet drops going on, like you see in here. So you see for both suddenly packet drops get active because I'm sending 2 flows through my switch with the same server class. If I would have created one with a lower server class, and that's something that I will do right now, send it out on the same on another TX. Right, let's take 11 in this case, and for instance, I have a bitrate of 5000. Label let's be original GVW2, and I'll take a lower service class of broadcast video. So broadcast video is a 6, standard is a 10. Let's take that one, execute now. What you will see is this one is dropped to 0. Why? Because the quality of service of these streams is higher, so they have priority above this one. If I would add another one, for instance, add multicast as a last example, let's go out on port 4 in this case, 5000 again, the label, and now I have broadcast video. One higher is multimedia streaming. If I send out on this service class, what you will see now is that this one has the full bandwidth, while the other ones are dropped even more. So all these flows that you see over here are also available in the multicast table. So all of these ones are added in here with the same parameters. So expected bitrate, packet drop, service class, and the label that I have added. So actual bitrate that we have, input bitrate. For me, this is important so that I know if I need to come back from a packet drop, that I know what's my maximum bitrate that is allowed for that one, that I don't suddenly go to 10, for instance. That's it for the multicast. All of this data gets aggregated, and so you have then also the values here on my different interfaces itself. So here I see I have 3 flows over here, RX flows, TX flows. I have some over here also together with the bit rates on it. Now, what I also showed in another video is when you have a multicast growing to several switches, and those simulated switches are next to each other. If a packet drops occurs on an outgoing interface, then also the next switch linked to it will have also that same dropped bitrate in there. That happens through DCF connections that we have between our elements. And how do we set this up? That's we do that with the LLDP tables, the ones over here. So what do we have? We have here the 4 tables like you can find on other devices. Some vendors have only 1 table, it doesn't matter. But the data in here, it's injected by a CSV file in which we define this element on this interface has a connection with that element on that interface. Then we have a script, we inject it in these tables, and then by making use of the IDP solution, we have all our DCF connections set up. Like you can see here in the connectivity tab, you see Ethernet 1 with my Ethernet 011, my 1 port, or my Ethernet 1 is connected to this element on the 1 port of it. So that's that. So then every change of the bitrate will also influence his neighbor switches. What do we have more in here except for the interfaces and the multicast? On the general page, so we have the system name, system description. That's an exact copy of the ones that you simulate, that you have configured on the simulation config page. But since we want to mimic a real switch and also a real element that we have, that we as Skyline are deploying in the field, we make this field read-only, so we make the configuration available on another page. Something that we also have here is CPU usage and memory usage. What have we done here? The more flows that are going through the switch, the higher the CPU and the higher the memory usage. So for instance, here you see there was already a flow on the switch, if you have noticed it. At this time, suddenly we see a jump in CPU usage. Same can be seen in memory usage over here. Also power consumption simulated. How do we simulate this? Well, in the IDP solution, for each CI type, we can define the average power consumption. This is filled in as a property. Energy expected consumption and energy peak consumption. So with the energy expected consumption, it's 5.0 0.004. So what we do, we translate this value to watt, and we do some randomized value between 70 and 80% of this value. And that's then filled in here in the power consumption. And with that, you also have a trend chart that you can see. Also, what we did is we added PTP parameters. So a whole PTP section is added to the switch, and this is in support of our squad that is working on the PTP solution, so that they can easily mimic PTP devices like they are used in the field. One last thing that we have here is the demo resources. That's just for each interface that we have within the CF connection. We can create SRM resources, but I would like to come back on that when we're actually going to talk about our SDMN solution that we're building on top of this switch.